Hello viewer, today we will be solving the IB Math AHL May 2025 paper 1 times on 1 question number 12. You will be getting the solutions for the first 11 questions from this paper and the other solved questions from the other past papers in form of playlist on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question number 12. The maximum mark is 19. Consider the family of functions fn of x equal to cos x raised to the power of n. This is nothing but cos x times cos x times cos x n times. Okay. So where x is a real number and n is a natural number. So part A's question is by writing cos x raised to the power of n as cos x raised to the power of n minus 1 times cos x, so that the integral of cos x raised to the power of n with respect to x is equal to cos x raised to the power of n minus 1 times sin x plus n minus 1 times the integral of cos x raised to the power of n minus 2 with respect to x minus n minus 1, the integral of cos x raised to the power of n with respect to x for n greater than 1. Okay, so by the format of this expression that is given to us, we understand that we have to use the by parts rule, because we have to find, first of all, write this as cos x dx. This should be equal to cos x raised to the power of n minus 1 times cos x and dx. Okay, we have to write cos x raised to the power of n in this form. And then we have to integrate. Obviously, we cannot use the substitution method or the partial fractions method. So we have to use the by parts method. Now coming to the by parts method, which one should be our first function? Both of them are trigonometric functions, so we cannot use the I late. Okay, but we know that the integral of cos x with respect to x is sin x. So better we can take this as u, the first function, cos x raised to the power of n minus 1. It is not that we cannot integrate this part, but since we know the integral of cos x directly, so let us keep this for getting integrated and let us take this as the u. Okay, so u is equal to cos n minus 1 x. So what will be its derivative? Du dx. It will be equal to n minus 1 times cos n minus 2, this should be within brackets, x, and then the derivative of cos x, which is equal to negative sin x. Okay, so therefore this should be equal to, first of all, it will be u, so it is cos n minus 1 x, and the integral of the second function, which is sin x. See, we have already got the first term, and then it will be the minus sign, and it is the differentiation of the first function, derivative of the first function. So it will be n minus 1 times cos n minus 2x and minus sin x, and the integral of cos x is sin x and dx. Okay, so this is equal to cos n minus 1 x sin x. I can take this minus sign outside, so it will be plus, and let me take out this n minus 1 also, and this becomes cos n minus 2x, and this is sin square x dx. And now you see over here we are having a single integral, but for this expression we are having two integrals, and we are not having any sign anywhere. So we have to convert this sine square to cos. So this is equal to cos n minus 1 x sine x plus, don't get afraid by seeing such a long and a strange type of an expression. It is very easy. Okay. So n minus 2x, and this will be 1 minus cos square x and dx. So this is equal to cos n minus 1 x sine x, and this will be plus, I'm separating. So n minus 1 cos n minus 2x times 1 will be equal to cos n minus 2x dx, and there will be now a negative sign and n minus 1 because of this minus sign, and then it will be n minus 1, and cos n minus 2x times cos square x will be cos to the power of n x. Okay, so this will be cos to the power of n x dx. Let us look at the given expression. See, plus n minus 1 times cos to the power of n minus 2x dx minus n minus 1 times the integral. This was the integral, again an integral, cos to the power of n x dx. Okay, for n greater than 1, if if n is equal to 0, they have said that n is a natural number, so the smallest value of n can be equal to 1, and if you have n value equal to 1, then cos to the power of 1x will be dx, the integral of cos to the power of 1x with respect to x, that is the integral of cos x with respect to x will be equal to sin x. Okay, and because when n equal to 1, this will be in 1 minus 1, this will be equal to 0. So this will become equal to anything raised to the power of 0 is 1. So this will be 1 times sin x, we will be getting sin x, and this will be 1 minus 1. So it will be 0. So this part will be 0, and also this part will be 0. So there is no point in taking n value equal to 1. Therefore, they have said that n value is greater than 1. Okay. And now coming to subpart B. So let me just read this, the whole thing, and this, we have shown this. Shown. Okay. And subpart B, hence show that the integral of fn with respect to fn of x with respect to x, that is the integral of cos nx, is equal to this part. Okay, and if n minus 2x, what is if n minus 2x? It will be cos n minus 2x. Okay, so don't get confused by this fn minus 2x expression. This is fn of x, so the power is n. When the subscript is n minus 2, the power will also be n minus 2. Okay, so subpart B, integral of fn of x dx is equal to the integral of cos nx dx. This should be equal to, let me just write this one, the whole thing. First of all, it is cos n minus 1 x sin x plus n minus 1. Now cos n minus 2x dx, this can be written as this fn minus 2. Okay, so this will be equal to fn minus 2x dx, and this one is minus n minus 1, and this is again fn of x. Okay, so fn of x dx. this is fn of x, this is also fn of x. So let us add n minus 1 times the integral of fn of x with respect to x to both the sides. Okay, so this becomes plus, I'm adding, so it is plus n minus 1 times the integral of fn of x with respect to x to both the sides. So this is equal to cos n minus 1 x sine x and plus n minus 1 times the integral of fn minus 2 x dx. And I'm not writing the addition of this term on the right side because this is plus, this is minus. This will be getting cancelled with this new term on the right hand side. Okay, so and now I can take out this portion as the common factor between the two terms of the left side. So this is integral of fn of x dx. It follows exactly the rules of algebra. It is just there is the integral sign. If you're confused, you can just substitute, let the integral of fn of x dx be equal to k, and don't substitute as x because you are having the x already. So it is basically k plus n minus 1 times k, and you are taking the k as the common factor outside. So this is just the simple logic, the simple algebra rules that we follow. So this from the first term, it is 1, and from the second term, it is n minus 1. Okay, and these two will be getting cancelled. So we will be having n times the integral of fn of x with respect to x. So this is equal to cos n minus 1 x sine x plus n minus 1 integral of fn minus 2 x dx. And now we will be dividing the entire equation by n. So because we need the integral of f of n of x with respect to x expression. So this is 1 over n cos n minus 1 x sine x and plus n minus 1 over n integral of fn minus 2x and dx. Okay, so you see 1 over n cos n minus 1 x times sin x and n minus 1 plus n minus 1 over n, and this for n greater than 1. So this is for greater than n greater than 1, and this is also for n greater than 1. Okay, so okay, so part C. Hence, find an expression for the integral of cos x raised to the power of 4 with respect to x, giving your answer in the form of p cos cube x sine x plus q cos cube x sine x, sorry, not cos cube, cos x sine x plus rx plus c, where p, q and r are positive rational numbers. Okay, it is cos to the power of 4x. Fine. In place of n, we will be writing 4. So subpart C, it will be basically, I'm not writing f4. Okay, let me write this. This is equal to f4x dx. Okay, and then we can use this expression. So therefore, cos 4x dx will be equal to n is equal to 4. Therefore, n is equal to 4. Okay, so 1 over 4 cos 4 minus 1 is 3 x sine x plus 4 minus 1 is 3 over 4 integral of if n minus 2. So 4 minus 2, it is cos square x dx. Okay. And now we have to integrate the cos square x. So we will be using the double angle identity. So it will be 1/4 cos cube x sin x plus 3/4. It will be 1 plus cos 2x over 2 dx. So this is 1/4 cos cube x sin x plus 3/8. I'm separating the terms. It is 1 dx plus 3/8 integral of cos 2x dx. Okay. So this is equal to 1/4 cos cube x sin x plus 3/8x, and this one is plus 3/8 and sin 2x over 2 plus c. So this is equal to, this is the integral of cos to the power of 4x with respect to x. It is equal to 1/4 cos cube x sin x plus 3/8x. And you see, this is sin 2x, but over here you are having cos x sin x. Okay. We are having this term 3/8x. So we have got this, we have got this. C only term which is differing is this part. So in place of sin 2x, we will be writing 2 sin x cos x. Okay. So plus 3/16, 8 times 2 is 16, times 2 sin x cos x. Or they have written the cos x first, so I'll be writing cos x first, and plus c. So therefore, cos to the power of 4x integral is 1/4 cos cube x sin x plus 3/8 cos x sin x plus 3/8x plus c. Fine. The region R, this is the region R, is enclosed by the graph of y equal to cos square x and the x-axis where x is greater than or equal to negative pi over 2 but is less than or equal to positive pi over 2, as shown in the following diagram. The region R is rotated by 2 pi radians around the x-axis to form a solid of revolution. Sapati's question is find the volume of the solid. Okay, so volume of revolution, you will be having this formula in your formula booklet. Even the integration by parts formula is in the formula booklet. So volume of revolution will be equal to, I'm not writing around the x-axis and all, it is pi and integral of y square with respect to x. Okay. So therefore, volume of the solid is equal to pi, and what is y square? What is y? Y is cos square x. Y equal to cos square x. So therefore, y square will be equal to cos to the power of 4x. Okay. So this is cos to the power of 4x dx, the integral of this. And we have found the integral expression for cos cube x, cos to the power of 4x with respect to x in subpart C. Okay. And this will be a definite integral. I did not put the limits, the upper bound and the lower bound. It should be between minus pi over 2 and positive pi over 2. So I have to write that part. And this is the expression for cos to the power of 4x, integral of cos to the power of 4x with respect to x. Okay, so therefore, volume equal to, we will not be doing the integration once more, obviously, pi and 1 over 4 cos cube x sin x plus 3 over 8 cos x sin x plus 3 over 8 x, and plus c, we will not be taking the plus c for the definite integral. We do not take the constant of integration because it will be cancelling. And now we will be substituting the x values. So this is equal to pi and 1 over 4 cos cube pi over 2 sin pi over 2 plus 3 over 8 cos pi over 2 sin pi over 2 plus 3 over 8 times pi over 2 minus 1 over 4 cos cube negative pi over 2 sin negative pi over 2 plus 3 over 8 cos negative pi over 2 sin negative pi over 2 plus 3 over 8 times negative pi over 2. Okay, and cos pi over 2 or cos negative pi over 2, these are equal to 0. So therefore, this is pi and this one is 0, this one is 0. So it is 3 pi over 16. And this one is minus 3 pi over 16, and there is this minus sign in front. So it will be plus 3 pi over 16. Okay, is equal to pi times 6 pi over 16. And I can cancel by 2. So it will be, volume will be equal to 3 pi square over 8 unit cube. Okay. Yeah. Now the subpart E, it is having two further subparts. The subpart I is saying, find the Maclaurin series of fn of x, that is cos x raised to the power of n, up to the term in x square. Okay. So EI, it will be fn of x will be equal to fn of 0 plus x times the first derivative of fn of x when x equal to 0 plus x square over factorial 2, second derivative x equal to 0, and so on. We will be stopping because it is up to x square. So if n of x is equal to cos nx. Okay. So therefore, okay, let me write, therefore if n of 0 is equal to cos x cos 0 raised to the power of n, in place of x we are writing 0, and cos 0 is equal to 1, is equal to 1 raised to the power of n is equal to 1. Okay. Now the second derivative, first derivative will be equal to n cos n minus 1 x and then minus sin x. Okay. So therefore, first derivative value when x equal to 0 will be equal to n and cos 0 raised to the power of n minus 1 and there is the minus sign, so let me write the minus sign in front, and sine 0. Sine 0 is 0, so this is equal to 0. Okay, and second derivative, this is equal to minus n cos n minus 1 x sin x. Now we have to use the product rule. So it is minus, first of all, let us differentiate sin x, it will be cos x. So it is minus n, and cos n minus 1 x times cos x is cos x to the power of n. Okay, and now I am differentiating this one. So this is minus n and sin x and n minus 1 cos n minus 2x, and the derivative of cos is negative sine. So this is equal to minus n cos nx, and there is this minus sign, so it will become a plus sign, and it is n times n minus 1 and sine x, and this is sine x, so it is sine square x and cos n minus 2x. Okay, so therefore, if double prime 0, if n double prime 0 equal to, it will be minus n and cos 0 raised to the power of n and plus n times n minus 1 times sine square 0 times cos raised to the power of n minus 2, 0. And sine 0 is 0, so this term will be equal to 0, and we will be having this one. Cos 0 is 1, 1 raised to the power of n is 1, so this is equal to negative n. Okay, so therefore, if n of x will be equal to, if n of 0 is 1, and okay, let us write this one, x times 0 plus x square over factorial 2 times negative n. This is equal to 1 minus n x square or over 2. Okay, and plus dot dot dot. So this is the answer for this first subpart of the subpart I. Okay, I hence or otherwise find. That means we can use this information, or else we can use the L'Hopital's rule also, limit x tends to 0. If n of x minus 1 over x square, because the denominator is equal to 0, and the numerator f n of x is cos x raised to the power of n. So when x equal to 0, not equal to, it is very close to 0. So it will be 1 raised to the power of n, which is 1 minus 1. So it will be a 0 over 0 case. So you can use the L'Hopital's rule, or you can else you can use the Maclaurin series for the expression for the f n of x. Okay, let us use the Maclaurin series expression. So hence or otherwise find the limit of x tends to 0 if n of x minus 1 over x square in terms of n. Okay, I limit x tends to 0 if n of x minus 1 over x square. Okay, so this will be equal to, I am writing this expression in place of f n of x, 1 minus n x squared over 2 and minus 1 plus dot 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 over x squared from EI. Okay, and this will be getting cancelled, and you will be having this is equal to minus n over 2 x square. I'm separating the terms, and plus dot 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 And I have to actually write the limit over here. You continue writing limit till you are having the x in the expression. Okay, so this is equal to n over 2 because terms containing higher powers of x will be 0 as x approaches 0. Okay, because the other terms, this is x squared, next it will be x cube, x to the power of 4. We do not know which term will be having a 0 value and which one will be a non-zero term, but they will always all be having the power of x more than 2. Okay, and when x is almost equal to 0, very small number, higher powers of a very small number will be even more smaller. So those will be equal to 0. Okay, so this is the limit minus n over 2. We have completed answering this question number 12. Thank you for staying with me till the end. Thank you for watching my video till the end. Since you have watched my video till the end, I may assume that you have liked my explanation. So please do like and share this video with your friends. And please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. It will be increasing my videos reach. It will be motivating me. It will, the YouTube will be showing my video to more number of students. So you will be helping me. You will be helping other students as well. And in our next session, we'll be starting to solve the paper 2. So till then, bye.